Hi, everyone. Welcome to our session where we're going to be going through understanding the Kibana dashboard. What I'd like you to do is we are expecting some more people to come in, but what I'd really like you to do is if you do have any questions, I'm very happy if you just want to interrupt me. So unmute yourself and just interrupt me. And also, if you want to put something into the chat, that's also fine. Maybe if you're in a situation where you can't necessarily unmute, but I'm very happy if you want to put it into the chat. I really would like this session to be as interactive as possible because I'd like to make sure that all of your questions are answered in terms of this dashboard. So what I'd like to do is that I'd like to start with the foundational knowledge of how all of these things work. So I'm actually going to go to, I'm now going to go to an IoT slide. So if we just have a look at this. So yeah, Internet of Things. And what we're doing here with the Kibana dashboard and what you're doing with your particular kit has got everything to do with Internet of Things. If it weren't for Internet of Things, we certainly wouldn't be able to run these kits. So, or get any data or anything like that. So let's just have a look at how this whole thing fits together. So with Internet of Things, you've got your things, which are the Internet of Things, where your data is being collected, wherever that may be out in an environment. So it's referred to as an IoT device. And step number one is that IoT device communicates via internet, okay, the internet, to some kind of a data center. Here it's referred to as a corporate data center. And then what happens is that data is then called back via the internet, step number 3, so that it can be displayed somehow on some other device. Not actually the same device, but on some other device. So what we could do, what we could see is that here we have a little machine like a robotic arm, and it's sending data via the internet to some kind of data center. And then what's happening is that data has been interpreted and it's going back via internet actually to some gauge or some other process controller, which could actually be on the other side of the world. It doesn't have to be in the same room at all. And so what it does is that this all enables us to actually do remote sensing. What that means is that we can have sensors somewhere out in the middle of nowhere, as long as they are able somehow to connect to internet, whether that means that they use a long-range radio or a satellite radio, whatever it may be, to connect to the internet, then we're able to see that data somewhere else in the world. So let's actually bring this back to how do we actually apply this with the programs that we're doing at the moment? So your kit that you've assembled, you've given it a device name when you configured it. So it has a name and you need to connect it to internet. And the way that you connect this particular core that you're using, your ESP32, to the internet is using Wi-Fi. So we need to make sure that we somehow have some Wi-Fi connection, so we are able to connect our kit using Wi-Fi to the internet, so that data can then also complete step number 2 and go to a corporate data center. In this particular case, that corporate data center is the Mqtt server called data.maxiq.space. So an Mqtt server is a particular type of queuing technology server, which is used for Internet of Things. Okay, it was a technology actually that was developed at IBM, probably definitely over 20 years ago, and it's now really coming into its own now that so many more people have got access to internet. The costs of internet connection are going down, etc. Now it's really coming into its own. So all of the data from your kit, as long as your kit is connected to power and internet, all of your data from that kit will be stored on our server. Okay. Now that means that if you disconnect your kit, it doesn't wipe that data that was added there previously. If somebody else goes maybe to your dashboard, which we'll see in a few minutes, maybe, and they change the name of your dashboard or whatever it may be, don't worry, they're not deleting your data. Your data will always be there on our Mqtt server. So now what we do is now we need to find a way how we can display that data. And so how do we retrieve that data? And we do that using a tool called Kibana, which we have on our internet browser. Okay, so the biggest, in fact, the only challenge with any of this, the only challenge of any of this is step number one, this Wi-Fi connection to internet, okay? The code that's on your kit definitely works, okay? And the reason why I say that is that every single one of the components that we ship out of our business gets tested. We load the code onto that core, and then we test that core. And we actually test it with our own internet connection to make sure that it is connecting to internet, that that whole process is working. So if you are not seeing your data on the dashboard, what it means is that you don't have an effective Wi-Fi connection to the internet. And that could be a number of different reasons. Definitely if you are in a school environment or in a university environment, very often those Wi-Fi, those guest Wi-Fis or those institutional Wi-Fis are locked down to exclude Internet of Things devices. So in that case, what we would do is we would actually then need to, we'd like you to introduce us to your IT personnel, so that what we can do is we can get them to white label your kit so that your kit is able to access. In a lot of circumstances, it definitely works if you use a hotspot on a smart device. It'll work, and a number of things. So when you configure your kit, when you configure it and you go through that configuration screen, you know, in the getting started video, we take you through how to get to that configuration screen. You know, so what you'll do is you'll put your group name in, your kit name in, and then the Wi-Fi SSID name, which is basically the name of the Wi-Fi plus the password. So it also needs to be a Wi-Fi where it has a name and a password. It can't just be one of these open community Wi-Fis where all you have to do is just join the Wi-Fi with that name. It needs to have one level of security. Okay, so once you've got it past that step, everything else becomes incredibly easy, because then your data is there, and all it means is then you just need to retrieve your data. So what I'm going to do is that I'm going to stop at this point, and I'm going to now answer some questions for you that you have. Okay, should I carry on? Okay.
Yeah, I think so.
Okay, great. All right. So this time around, what I'm going to do is I'm actually going to go to a browser. Right. So I'm going to go to my browser. Actually start this again. And so what I'm going to do is I'm going to put in data .maxiq.space. Okay. Now, because I've already accessed this Kibana dashboard so many times, I don't need to put in my username and password. However, the username is the first part of this domain. The username is data, and then the password is maxiq. Okay, and then it'll let you in. And I really do recommend that you save that. Okay, so whenever you come in, what it's going to do is it's going to say to you, I've got no results found. Okay, and we know that, and there's this very specific reason for that. Okay, I'm actually going to go back to my slide. I'm going to go back to my slide and show you here. Okay, so you can see here this corporate data center. There's many servers that are sitting in this data center. And an Mqtt server, what it does is that it has a number of indexes. And it's a little bit like a reference library. If you were to go to a large reference library, you can't take the books out. You can only use the books while you're there at the reference library. But if you went into this library, which had like many floors of books, and these are chasms of shelves, then you wouldn't be able to go through every single shelf, every single book to look for the book that you were looking for. So what you would do is you would go to a librarian, or you go to an index, and you'd say, I'm looking for this particular topic. So I'm looking for geography, and then I'm looking for something that talks about, like, I don't know, mountain formation, etc. And then what you would do is you'll be then pointed to the correct shelf on the correct floor. Okay, so somebody put their hand up. Okay, Declan, please, absolutely. Let me stop sharing, and if you want to ask a question.
Hello, sorry,
Hi.
I was
That's good.
wondering, with the SDG index, who are the people using it? Because I was playing around with it and I saw there were hits coming from America as well. So who's using it? What kind of projects are using that index? Okay,
so yeah, this SDG kit is supplied across the world. So there's thousands of those kits out there. So yes, you would certainly find that there are people across the world. So what I'm going to do is I'm going to get to that, okay? And then I'll actually show you, we've got a great map. We've got a great map for that. So if we just go back here, so in terms of this data center, what we have is we have many indexes here. So what you need to do is, in order to find your data, you need to actually go to the correct index. So let's go back to our browser, and what it is that as many SDG kits that there are out there in the world, there's probably 10 times as many of the first version of the kit, which is where it points to the weather station index. So that's what democracy is about. The majority rules. So the majority of the people who've connected their kits are going to the weather station index. But what we've got is we've got a newer version. And so what we do is we go to the SDG index. So when I open up this little arrow over here, you'll see we've got high altitude balloon missions, we've got CubeSat missions, we've got some that are running in greenhouses. This is for the International Space Station. Here, for a particular program we ran last year on the International Space Station 2021. Here we've got MSU is Moorhead State University. Here is one for all of those who are running pot plant experiments that we were doing last year. This is for all of those who participate in the Small Sat conference, which happens every August, every year. In fact, I think it was like 3 years ago or something. It was the 30th one that they'd had in a year. So this Small Sat index has been here since 2016. So definitely for the last 6 years, they've been using that one. The solar eclipse of 2017. This is a particular kit. The XK07 is a particular remote sensing kit with many advanced sensors, and that uses LoRa radios, long-range radios, etc., for wilderness sensing. There's another advanced kit called the XK92, etc. So we're going to go to SDG. So if we go to SDG and we don't put any kit name in, we can see that there's a whole bunch of kits connected here. So we can see that at any timestamp that's created, there's 16 or 17, maybe even 18 kits connected that are delivering data packets over that 5-second period. So what I'm going to do now is that let's actually go to Declan's question, and where are all of they connected? And what I have got is I've actually got something over here that's called Kits Connected. Kits connected over the last 6 months, let's put it that way. And there we go. So what we can do is we can zoom in a little bit. Oh, there we go. No, we have to zoom out. Okay, so the size of the circle denotes how many are connected at a particular time from that location. So we can see we've got a number of kits connected all over the African continent. We've got 1 or 2 kits connected in China. We've got one over here in where is that? France, I think. East coast of the US, more kind of central US, the west coast of the US, quite a number of kits over there. So yeah, so you can see here sort of a bit of the footprints of the different kits that are connected. So let's go back to this Discover tab. So on the Discover tab is important, because what we actually want to do is we want to see what data we have available. So what I'm going to do is I'm going to say, okay, over the last 4 hours, right? Did you see I opened up this gray bar here and I changed it? It opens up quick over here, so I could change it to whatever I wanted it to be. Last 4 hours, which is fine. And in front of this asterisk, I'm going to put my name. I don't have to worry about uppercase, lowercase, or whatever. Another thing is when you put together when you enter your kit name, please don't make it too long. Sometimes I find that if the name is too long, or it has more than one space in the name, or if it's got like dashes and exclamation marks and that kind of thing, then it doesn't show up in the search. So if you could just, maybe just make it relatively easy. So I've put my name in here, and I'm going to click this little search on the right-hand side. And now I can see that, fine, what I've got is, you can see here that for my kits, it's called Judy Blue Shift. And you can see over any one period of time, it's delivered 53 data packets, 52 data packets, etc., etc. So now what it's doing is, here it says here count. Now it's counting data packets. Okay, so what I want to do is that I want to look, and I was like, okay, so what is inside that packet? That packet of data. So what it is that we use in terms of the communication, we use a format called JSON, J-S-O-N. So what happens is that it creates a JSON file, and then what it does is it packages it into what's known as a data packet. And then that data packet is then communicated via internet to the Mqtt server. And once it lands there, then the packet is basically unpacked, and then the data is saved there in that index on the Mqtt server. So let's open this up. Let's actually see what we have. So you can see here what I've done is I've just pushed this arrow for this particular data point over here, which was at just only a few seconds ago. Okay, so let's just see over here. So if you wanted to look at the JSON file itself, actually what I want to do is that I want to stop this from refreshing automatically. So you see I've gone to this gray bar again, I go there and I say, turn refresh off. Because otherwise it's going to keep refreshing, and I'm going to keep having to hunt this data point of mine. Okay, so if we wanted to, you see what we can do is we can open up the data table, or otherwise we can have a look at the JSON file itself. So this is what the JSON file looks like. Okay, it says this is my index, this is my type JSON, etc., etc. What is my chip name, etc., etc. Now, for me, this looks way too much like code. Okay, so I never look at that. What I do is that I look at the table. This is something that I can understand. Okay, because I'm a chemistry specialist. I'm not a coding specialist. Ask me anything about chemistry and I can probably answer it. But so I need a table. I'm like fairly binary. Okay, so timestamp created. Okay, so it's got date and time over here. And then this is now an ID. So this is the chip ID. Every single one of your cores has got a very unique chip ID. So that is that unique identifier. And it says index here, STG, that's perfect. Okay, and then type is JSON. And then here's another chip ID. Okay, and so this is an assigned number. Okay, so this is you can see here 9 million and something, which is great. It's different from this ID. Okay, this one is based on what it was assigned at the factory, and this is what is assigned in terms of the code. And then this is it's a dual core. So this is just showing that you're running a core that has got 2 cores, a chip that's got 2 cores. Some of them have got 1 core. And so sometimes it's nice to know the difference, especially if you're doing much more advanced projects where you actually want to use one of the processors for storing data and the other one for processing. Then it's nice to know that you've got these 2, that you've got a dual core processor. Okay, the flashed memory is 4 megabytes. The mesh code, etc., the speed, the frequency. So this is very important when you have a look at if you want to use, like for example, serial communication, which we would get to in a much more advanced version of this program. This chip frequency and the chip speed are very, very important, because you don't want to be setting it up at a speed that it can't handle. Okay, you know, at a too fast a speed. Chip model ESP32, that is great. Revision is number 1, and internet cellular data true. Okay, so what that means is that my kit is connected using cellular data. Okay, and the internet city is Cape Town, Western Cape, South Africa. So these 2 are related. The cellular data and the internet city are related. So for example, I mean, I'll let you know what it is that I connect using Vodacom, and Vodacom's access to the internet pipe, the CCOM cable, is in Cape Town, Western Cape, South Africa. If you are using an internet provider, like maybe you're using MWeb if you're in South Africa, or maybe you're using AfriHost or something like that, maybe you're actually in Durban, but it says that your internet city is Johannesburg or Pretoria or something like that. What that means is that it's not reflecting where you have connected your kit to Wi-Fi. What it is it's reflecting where your service provider has connected to the World Wide Web, the internet. Okay, so you don't have to fear this local IP or this internet location, this longitude and latitude is not giving away your physical address. Okay, it's not giving away your address. If we were to look on a map at this latitude and longitude, we would see that this was actually Vodacom's connection in Cape Town, which is something like 30, 40 kilometers away from far away from me. Okay, so that's my local IP. Public my internet SSID. So I call my Wi-Fi Vikings friends. Okay. Our dog's name is Viking, and so our guest network is called Vikings Friends. And you can see here internet time zone offset. Okay. 7200. So what that is minutes. So what is 7200 divided by 60? Okay, so what's going to happen is that this is the offset, and I'll show you why just now when we get to the dashboard. Is that it's taken this offset and it's calculated it from this internet location, in fact, from the longitude, okay? So that what it can do is it can set it to, it can keep the time zone, okay? So this is why this is like a time zone offset. In fact, no, it's not a 60, it's, let me get out my calculator. So what it is it's 7200 divided by 60 equals
I think
120.
I wrote it
Yeah.
up. Yeah, it's 120.
That's 2 hours.
2 hours.
Okay, so that's 2 hours. And I do know that we are sitting at UCT -2. So that's the 2 hours offset to get us to UTC, which is a universal time constant, or a Greenwich time meridian, whatever it's called. Okay, so yeah, that's great. So that is 120 times 60. Now we start getting to the sensors. So we've got a light sensor. So it's saying right now it's measuring a light intensity of 476 lux, and it's got a UV burn time, okay, which is never. Okay, who is going to tell me what a UV burn time is? Come on, I'm sure you can tell me what a UV burn time is. Hazard a guess. Okay. UV burn time is the number of hours you can be in sun of this intensity, and you get to a position where your sunburn could start to develop. Okay, now this kit is sitting in the corner back there in a pretty dark area, so a lux level of 476 is unbelievably low. So I'm never going to get a sunburn. I'm never ever going to get a sunburn at that. So that is what this burn time is. Yes, Declan, please go ahead.
That's something I find interesting though, because that doesn't sound like the kind of thing which would be sensed, rather something that would be calculated, right?
Absolutely.
So is it calculating it on the board? Is it part of the programming to calculate this data and then send it with the JSON file? Because if so, why doesn't it calculate it on the server?
Okay, so that is a very, very good question. Okay. And I hope you noticed that I had to think a little bit, okay? Because it's not calculated on the kit. It's calculated on the server. So what is happening is that the light sensor data, the light intensity, the lux and the UV, okay, is via internet, is being communicated. It's being stored on the data center. All of the calculations are done on the data center. And then what it is that then it's packaged into the JSON file that then comes back in step number 3 to display on your device. So there's one JSON packet that goes from your kit to the server that's saved on the server. Then the number of calculations are done. And then when you call, when I put in my kit name and I then called the data, that JSON packet that is then sent back to the Kibana dashboard includes the outcome of the calculations. Does that make sense?
Yes, thank you.
Okay. So the server is able to do so many more calculations than your kit can. Okay. Also, the thing is that your kit, you've got this tiny little screen, so we can't display much on that screen, right? So, I mean, the most we can display on that little screen is like light intensity and UV index. Because if we were to display everything else, it would just get so busy. So those calculations are not done on board on the device. Those calculations are done on the Mqtt server, and they are presented via the dashboard. So if we go back to the dashboard, that is why it's so important that you are able to connect to Kibana and see what data is available on Kibana, because you wouldn't be able to see this. And there's so many more calculations that have been done that are not just available on the straight kit on its own, okay? If you want to calculate something, if you want to calculate a factor from the data, let us know. And then what we can do is we can arrange for Bianca to then actually take you through a session of how you actually work with the Mqtt server and how you access the server directly to actually build in those calculations, okay? It's pretty hairy for me, but for him, he can do it with his hands tied behind his back. Yes, Declan. Yes, you have another comment or question.
I'm so sorry, I keep asking like question after question, but regarding like these calculations, obviously there's like a bunch of different devices now, and we're currently sorting by like the SDG index. If I make a change where it says every JSON file must include this calculation, will that affect the entire index? Or what will it affect? To what level? And how does it know what to affect? Because sometimes, of course, there's data which isn't being transmitted.
Okay, I can't answer that question directly myself, but what would happen is that if you were to make changes, Bianca would never give you access to a live index. You would be working in like some kind of a sandbox environment so that you didn't affect everybody else. When it works, yes, maybe then it would be implemented on a live index as an improvement or something like that. But don't worry. No, you would never. Don't worry. You wouldn't be able to affect everybody else's data, because we never ever allow any development on a live system. if that makes sense.
Yes, thank you.
Okay. Because there's plenty of indexes that can be created and all of that kind of thing for that kind of experimentation. So yeah, but that's cool. Absolutely wonderful. Okay, so yes, so we have the UV index, which is incredibly low because I'm inside, and here you can see light UV rating, none. Okay, so of you may find that if you've been using your kit in the full sun and then you have a look at the dashboard, it could say over here, it could say maybe dangerous, or it could say harmful or something like that. So this is a text field. You can see here it's got this little T, which means it's a text field. That the UV burn time is also a text field. So this is just kind of like, these are different levels of what it may be, kind of warning. So what you could do is you could set up for yourself some kind of like an IFTTT routine where it says, where you could say to, where you could actually code it to say, and you could do this, I mean, Brittany, you know, help me if I'm wrong, but you know, what you could do is you could set it up where you could say, if the UV index is higher than X, then warn me or send me a text message or send me a WhatsApp or send me, you know, something like that.
Yes,
you know, if this and that, yeah, great. Brittany, yeah, thank you. Brittany, I'm also very happy if you want to interrupt me because, you know, you never know. I may be just completely wrong.
You've been doing well so far, Judy. You have.
Thank you. Thank you. That's cool. Okay, so let's go a little bit further down. So then, yeah, timestamp captured, and then my group name for this, that this particular kit is in, is called Blue Shift Scarborough, and my unit name is Judy Blue Shift. And then I'm running the code version 1.3, and this is like really important because earlier this year when we were sending kits out, that was version 1.2, and then we had to change the weather center because suddenly there was a chip shortage, and then we needed to actually put another sensor on the board. So we had to change the code so that it could suit the old sensor plus the new sensor. And so now we're on version 1.3. So it's really important that you're able to see which version you're running, because if Yarka adds another functionality, or for example, if you were to get another sensor, like for example, if you were to receive the accelerometer or a gas sensor or the barometer or something like that, then you would want that added to the code. And so then what he would do is he would then release a new version of the code, and you would then load that version of the code. So it's always very nice to know which version you're running. I find it very useful because if people say they've got problems connecting something, I can go to the Kibana dashboard and I can see which version they're running. And then I can see whether they need to update or not. So this is cloud-based. So this comes from the weather sensor, and this is calculated from a combination of air temperature and relative humidity, will give us cloud-based. So this is another example of a calculation that's taking place on the Mqtt server, not on the kit itself. And so therefore it's available on the dashboard, but it's not available on your OLED screen. So it says here that whatever it was 20 minutes ago, the cloud base, and I can see it actually is cloudy, just under 700 meters above ground level. The cloud temperature would be 17.658 degrees centigrade. The dew point would be 18.804 degrees, which is pretty high. And our heat index, it's 24.891. Okay, so I took the dog for a walk earlier, around about 12 noon. It was so hot and sticky. It was very, very, very uncomfortable. But it wasn't hot, yeah, but it was just so uncomfortable. And because the heat index is that, it's that comfort level that we saw a few weeks ago when we had a look at comfort levels. The heat index is calculated based not only on temperature, but also relative humidity. How humid is it above what is normally comfortable, and then that's factored in. So that gives us the heat index. And it says over here, heat index warning nominal, which is, that's kind of like, it's okay. It's not average or whatever, it's nominal. It's kind of like still acceptable. It's definitely not dangerous or something like that. But it's okay. It's kind of tolerable. And then our humidity, you can see here, pretty humid, 70.4%, and our temperature is 24.543, and you can see that's slightly lower. That's slightly lower than the heat index, because the heat index is taking this relatively high humidity and adding it there somehow in a calculation. Then we have a wet bulb temperature, which is 20.569. And these are all calculations that Milena loves, okay, because this tells her so much about what is happening with the weather. Is the weather clearing up? Is it going to become more cloudy? Is it going to become less cloudy, etc.? I have to say that at 5 a.m. this morning, we had quite a thunderstorm, which was unusual for this time of the year. But so our weather's been very iffy today. So that's our wet bulb temperature. Okay, so these, a lot of these are calculated, and then we have some. You see where this is a number, so this is the data that comes from the kits, as well as the temperature, etc. Now this Wi-Fi MAC address, this MAC address is the address that we would give to your IT people at the school to say, please white label this particular MAC address. Okay, so when you connect your kit and you scroll through all those screens, you will actually come to a screen where it'll give you the MAC address, because otherwise, if you can't connect it to the internet, then you're not going to be able to see it here on the dashboard. So you have to be able to see it on the kit itself. So the MAC address is there. And then my Wi-Fi RSSI is -46, which is okay. Not great, but definitely tolerable. Okay, so this is how much information we have available, because it's more than data, because some of it's actually being converted to information, because it's really informing me in terms of, what is my heat index? Should I go outside? What is my UV index, my UV safety rate, etc. Okay, so another thing that's really important here is that this is showing me what I have available, what fields I have available, so that when I build my dashboard or when I build a visualization, I'm going to build it around a field that I know that I have available. Okay, so at this point, I'm going to stop and I'm going to ask if there are any questions. Okay. Now we're going to start getting into the weeds. All right, have you all braced yourself? Okay, good. So now let's go skip to dashboard. Okay, so what I want to do is I'm going to go to the main index of dashboard, and I did something that said something to do with March 2022. Okay, so this is my weather prediction that I was doing for Milena's experiment. I tell you, look at this. You see, this project for Milena is not easy, because trying to have the kit outside where it's not going to be in the rain, but also where it's not going to be hit by direct sunlight. I've had to move this kit a few times because you can see over here, there was like a shaft of light that came in for about a minute, 2 minutes, and it just like, it killed my data. Because my temperature just jumped over there as well, and all of that kind of thing. So I do know that, you know, here it's fine, you know, from here on. So, you know, that's kind of okay. We can see here on this, this is, by the way, this is the normal template dashboard, okay? The SDG template dashboard. So here we've got a number of things tracked. We've got heat index. Slightly below that, we've got temperature. Then we've got wet bulb temperature, and we have dew points. So you can see here that the temperature over here, the air temperature, you know, when it was starting to get, you know, sort of like, you know, 5 a.m. in the morning on that particular day, it was, you know, it was starting to get a little bit close to what my dew point was. You know, I was like a few degrees away from dew point. So it's gonna be really, really interesting when the weather gets colder to actually see if those, you know, if they like cross over the temperature and the dew point. That's going to be really, really interesting to then observe if there is in fact dew out there. So what I did with this is, so I made sure that it was pointed to my kit over there, okay. And then I've got my data table here, etc. Okay, now, and I don't have my soil moisture sensor connected, so I'm not worried that I have nothing there. This is something that I really need you to check on, okay? And that is, if you go into any of the visualizations, okay, so here I've got this one that says, you know, ambient light, SDG ambient light. If I'm going to actually zoom in a little bit here. Come, let's zoom in. Okay, I go to this little pencil over here and I click on this pencil, which means edit the visualization. So where you have a dashboard is made up of a number of visualizations. So if I actually go to this visualization, okay, now it can look very different. And why is that? That is because it's for all the kits, and it's doing an average of the light of all those kits around the world that were connected at that particular time. So it could be morning my time, it could be middle of the night in the US, it could be the night, it could be afternoon before in California, etc. It could be all over the place. So what I need to do is that I need to make sure that it's actually pointing to my kits, okay? So if I put my name in there and I just search there, and then I run it again, okay, now I can see that there is that peak. That is absolutely fine. So I'm all right there. I'm all right there. So the thing is, what's really important is that you go and you check that somebody hasn't hard-coded their kit's name into the visualization itself, okay? And what I do, just to be absolutely sure, is that what I do is that I do exactly that, okay, is that I go into edit mode, I put my kit name in, okay, I search for that, I run it again just to be safe, and then what I do is that I say save the visualization, and I say please just save it as Judy, SDG ambient light, okay, and then save as a new visualization, absolutely crucial, save it as a new visualization, and I'll say that, okay. Now if I go back to my dashboard, right, I've still got the old one, so what I do is I click on this little cross here and I delete that, then I go add, And that one was Judy, SDG, ambient light. Okay, and then I close that ad again, and you'll see it will have added it here somewhere at the bottom. Here it is at the bottom. Okay, so I say that's fine. These little arrows, I just drag it up and I put it here up at the top again. Okay, now I know it's mine. And so what I'm going to do is I'm now going to save this dashboard again. I don't have to save it as a new one. It's already got my name. And I want to save this the time here with this dashboard. So I click this checkbox here and I go save. So what I would really recommend is if you're going to use a template dashboard, don't just take it as face value. Rather just go in, customize each of the visualizations for your own kit, save it as your own name, delete and add it back again. So you know that this is actually my dashboard. And if anybody goes in and puts their kit name into the template or whatever, it's not going to mess with mine. Because it can happen way too often that people go in and they make changes or whatever, don't save it as their own, and then we end up getting like really, really weird results. Okay, so are there any questions now with that? Okay, now what I'm going to do is now I'm going to show you how to create your own visualizations. Okay, so I'm going to share again. Okay, now you can see, remember I skipped over a tab. Okay, so what I'm going to do is I'm going to go to visualize. Okay, it still have my old visualization, so I just go to the main menu of visualize over there. And now there are thousands of different visualizations. That's why it's really important to save it with your own name, okay? But what I want to do now is I actually want to create a new visualization. So I'm going to say over here, create plus, okay? Create new visualization. And now it gives you all of these types, right? What I did is that when I remember much earlier in the session where I showed you the map, that's called the enhanced tile map. Okay. That took me probably about an hour to put together, not because I don't know Kibana, but the thing is, it was the first time I was actually doing a map for myself. And there are so many videos on YouTube, learning videos on how to use Kibana. And there are so many help pages and forums and everything else, because Kibana is the most used platform as an open source dashboard. So there's so much help out there. So really, if you want to create one of these things, like you actually want to do this first 3D chart on Kibana, I've never tried it, but you know what? If you want to be brave and you want to try it, all you do is like, how do I create an area 3D chart on Kibana, blah, blah, please help me, whatever. And so, you learn how to do these things. Okay, so it's got all of these things. There's the data table. In our template, we had a data table. There's a gauge, which it'll like move up and down. Health metric, where it just gives you like one big number. A heat map, which is a graphical representation of data where the individual values contained in a matrix represented as colors. So, if there's like more of one, you can make sure that that is red or green or something like that. A line chart, which is, quite simple. Markdown widget for displaying explanations or instructions for dashboards. One big metric, a network diagram, a pie chart, swim lanes. So this is really interesting, because what you could do is you could have different data and how they vary over time. You can have a tag cloud, so that it gets larger the more times it's like that, so you could have a tag cloud, for example, for, you know, like UV index or like UV burn rate or something like that, burn time or something, where it's just like, now it's dangerous or something like that. You could do something like that. Tile map. I haven't actually used this one myself. Time series, traffic charts, vertical bar charts. Okay, so what I'm going to do is I'm going to do a line chart. Honestly, this is the one I use the most myself. Now what it does is now it opens up and it says you can do it from a new search or a selected index or from a saved search. Okay, so what we're going to do is we've got a whole index at our disposal. So we're going to say SDG index. We're going to say this relates to the SDG index. So please, I want you to build this visualization based on the SDG index. Okay, so here we go. There we go. And I'm going to zoom in a little bit. And what it does is it gives me one little dot over here with some very large number, and it just says count. Okay. So what that says, okay, I must actually change this because this is still sitting here from that visualization I had. I'm going to say last 12 hours. Okay. If we look at this count, what this says is that over the last 12 hours, 23,372 data packets have been posted to the SDG index. Okay, so that's not very useful for you. Right, so I'm just having a sip of cold drink here. Okay, so what I want to do is, first of all, I want to say this relates to my kit. Okay, great. Now this number should have decreased, and now the number is 7,560 data packets for my kit in the last 12 hours. But that also doesn't really help me. So what I do over here on the left-hand side is I open up the y-axis, and it says, okay, so what do you actually want to know, Judy? Do you want the count? Or do you want average? Do you want all the data to be summed? Do you want the medium, the minimum, the maximum, the standard deviation, the unique count, the percentiles, percentage ranks, top hit, etc.? When I'm drawing a line graph, what I do is that I always use average. Okay, and the reason for that is if I'm looking over the last 12 hours, in order to display it on my line graph, I'm probably going to have data, a point for, let's say, every 30 minutes, or maybe at most every 10 minutes. Okay. However, my kit is sampling data every 5 seconds, right? So it's got this like waveform, okay? The data's kind of like, if I say maximum, I run the risk that I'm going to be displaying data that's actually abnormally high. And the same for if I were to pick minimum. I guess you could use median, but average is a much better mathematical term to have. So what I would want is over that particular sampling period, I would want the average of those different time segments. Okay, so that is why I usually go for average. If you want to, and I actually recommend it, you know what, create visualizations and try all the different facts, try all the different scenarios, and see what it reveals for you. Okay, so over here now is the field. Now this is the drop down. Here you can see, now this looks very familiar, doesn't it? Okay, this is all of those fields that we had on the Discover tab, okay, in our JSON file. What it's doing as well is it's giving, some other temperatures. You see over here, chip temperature. So this is what you could do, is you could actually set a warning to say my core is getting too hot or whatever, because the core does actually measure its own temperature and it posts that, but it's not coming from an actual temperature sensor. So this is not air temperature, this is actually chip core temperature. So that's not scientifically interesting, but it could be very, very, very interesting from an engineering perspective. So what I'm going to do is that I'm going to say, I want to have a look actually at Cloudbase. I want to see what Cloudbase has been doing over the last 12 hours. That's going to be very interesting. Okay, and so here I'm going to say Cloudbase, and I know it's in meters. Okay. You don't have to put a custom label in here. You know, the thing is what it does, it gives this funny like weather.cloudbase, and it looks like a little bit too nerdy for me. So I always put something like that in. Okay, and so then I just run that. Okay, so now what it's doing is it's saying to me, the average Cloudbase was 708 meters, but it's only giving me one data point because I haven't actually told it what my x-axis is. I've only told it what the y-axis is. So what I could do is, okay, you know what, let's actually add a metric here. And let's say what we want to do is you want to say, what would work quite well with that kind of number? Relative humidity. Okay, let's see what that does for us. I'm going to say here, that's relative humidity as a percent. Okay, that's cool. Let's run that. Okay, so here I've got my Cloudbase in meters, around about 700 meters. And here I've got my relative humidity at around about 70. Let's see if this is actually going to make sense at all, but that, you know what, that doesn't really matter. That's absolutely fine. Now let's go to our x-axis. So with our x-axis, sorry, I now need to just zoom out a little bit here so that it shows it to me. Okay, so on my x-axis, what I'm going to do is say date histogram. The reason why you're saying date histogram is when we had a look on Discover with the timestamp, it had the date and it had the time. So that's why we need to say date histogram. Otherwise, if you're looking at it over a longer period of time, if you only say histogram, then it's going to say, oh, 12 noon, but like on what day? So it's going to be a little bit too confused. Okay, interval, I'm going to set that at auto, but you can see here I could say I want a data point every millisecond, every second, minute, hourly, whatever, but I'm just going to set it to auto, so it'll just scale it itself automatically. And I'm going to put here date and time. Okay, and now I run that. Now we can see, okay, so that's quite interesting. It doesn't look as if my relative humidity has changed much, okay? But look at this Cloudbase, from 6:10 a.m. this morning, wow, 632 meters all the way up to over 850 meters at 20 to 1 this afternoon, okay? So you can see here that what it's doing is it's displaying it to me in my time, because it knows my time offset. The Mqtt server is actually sitting in Virginia in the USA in Eastern Standard Time, which is 6 hours away, 6 hours behind us, okay? But because it knows where my kit was connected, it's going to show me the time that is relative to the kit, if that makes sense. So yeah, we can see that this has been varying quite considerably. What I'm going to do is I'm actually going to change this, and I'm going to say last 24 hours could be very, very interesting. Okay, so that's quite fascinating. 2 o'clock in the morning, the clouds are coming in pretty low. Right, I wonder what Milena would say about this. Milena, are you with us? I'm just, this would be like would be a wonderful hour lesson for me from Milena. So Now I want to save this. I'm really, really enjoying this. So I want to save this, and I'm going to say save as new visualization. And I'm going to say Judy 24-hour cloud-based. Okay, save. Great. Okay, so there I have it. Now, what I can do is that I can go to my dashboard. And remember, I was on my dashboard. That's my particular dashboard. I can add that. I can say over here, I know it said something to do with cloud base. Close that again. And it's appeared somewhere here at the bottom. Isn't that wonderful? Okay. So you can see here when my visualization is quite small, you know, the relative humidity is not coming through all that great. So, you know, I may actually want to go and delete that or something like that. Okay, so yeah, do we have any questions? I've now shown you how to do a dashboard, how to do visualizations. Actually, no, let me show you one last thing. Okay. Oh, sorry, I just want to save that. I want to save this as a new dashboard. I'm going to say Judy 24-hour. Save. Okay, so I'm saving that as a new dashboard so I don't mess up my project for Milena. Okay, so what you can do is you can go here to dashboard. And once again, you can just create your own dashboard. So we can say over here, plus. Did I draw that line? Probably did. Okay. And it says here, this dashboard is empty. So you see this, I'm actually going to zoom in a little bit. You see here, it says this add. So I'm just going to add. And then now I can have a look at this. So I can say, what was that? There was something to do with cloud base. There's my one that says 24-hour cloud base. We can add that. Something else that involves Judy, which could be interesting. March. Temperature data, March 2020, whatever that may be. That's fine. Let me just close that again. So here, you know, I have two quite nice visualizations. I can drag this to below there. I can now expand this across here by just pulling it. And then this one as well, the same. Yeah, so you know, now what I can do is now I can see how they track with each other. And then I could save that, of course, again, save as a new dashboard, and I can just say Judy experiments March 2022. Okay, so that I can go and I can find it again. Right, so okay, we've been at it for just over an hour, so I'd like to know if, please ask me some questions. Yes, Megan.
Hi, Judy. I was just wondering, for Brittany's experiment design, create a new dashboard. I just did it on my original dashboard and collected the data from that and then took a screenshot and uploaded it on the assignment. Is that fine?
That's fine.
Okay, perfect.
That's absolutely fine. Also, the thing is that, Megan, if you wanted to, you could go now and you could actually create a completely new dashboard for yourself because your data is there. Your data is there forever. So, you know, if you wanted to actually design a completely different dashboard, you could do that just based on the same data. But that's, that's up to you. Yeah. Declan, hi.
Hello, I was just wondering regarding the Kibana visualization. I was looking at the cloud-based one you made, the 20-hour one, and I was wondering whether there's any way to like make the extremities of the data set more visible. Like say I was running an experiment where I wanted to see if the relative humidity decreased, then the cloud-based increased or something, just trying to find a relation between the two. On the one you made, they're such vastly different data sets where one's in the 1,000, in the thousands, and the other between 0 and 100. How would I compare the extremities of them rather than the exact numerical values?
Yeah, I agree. I mean, there it is now. Yeah, I don't particularly like it because, as you say, because this is, from, 370, to over close to 900. We can see the range there in terms of the cloud base, but we can't actually see the range in terms of the relative humidity. So for this to look better, what I would actually do is that I would separate them and I'd have them as separate visualizations. So what I actually want to do is that I want to remove this relative humidity. So you can see here where I've got it here with my y-axis, average weather dot humidity. What I'm going to do is I'm actually going to remove that dimension. So I'm going to click on this little red X. Okay, I'm going to run it again. And now you can see now I've only got cloud base. Okay, so, but that could also not be very useful to me. So can you see here, there's this little gray button here on the left-hand side that says options. So you can go to options and then you can say scale y-axis to data bounds, which means that as the data comes in, it'll actually move the axes, this y-axis up and down to the data bounds. So the minimum is not going to be 0. The minimum is going to be the minimum. I mean, yeah. The minimum is going to be the minimum and the maximum is going to be the maximum. So if we just run that again, push play, now you see now what it's done is it's done exactly that. The y and x, the y-axis crosses the x-axis not at 0, but at this minimum point over here, which is 386.305 meters, and then we've got our maximum over here. Okay, and if I were to refresh this constantly, it would move. So what I'm going to do is I'm actually going to extend that, and I'm going to say how have we been doing for the last 7 days? Okay. Now you can see, wow, okay, so there on the 17th of March, the cloud base was over 2,000 meters, okay, and then it went down. The lowest it's been was actually March the 22nd at 3 a.m., okay, so that was yesterday morning at 3 a.m. was the minimum. So that now, now it's starting to get pretty interesting. So what I'm going to do is I'm going to save this. Okay, so I'm going to save it here, and I'm going to say, I'm going to call this now, I'm going to save it as a new visualization because I'm going to call it a 7-day cloud base. Okay, so let's just save it at that. But now the thing is, what I want to do is now I want to have a look at relative humidity. So what I can do is that I can take exactly the same visualization. Okay, I can go back to where it says over here, data. And I can say, you know what, I no longer want the cloud base. What I actually want to do is now I want relative humidity, don't I? So I go here to my weather chip and I say humidity and I go run. Now, isn't that interesting? Now it's going from, now it's looking at humidity. And it's going from, and it's not cloud-based, it's relative humidity as a percent. Oh, sorry, percent, okay. That's fantastic. And so you see how little work I needed to do there just to change the visualization. And now what I'm going to do is now I'm going to say save as a new visualization. And I'm just going to go here and I'm going to say, save that as 7-day relative humidity. Okay, save. And that's actually going to make a pretty nice dashboard. So what I can do is I can go back to that dashboard that I had before. I'm going to need to delete these old ones. So I just delete those. And then I'm just going to add, and I had something to do with 7-day. So we add the cloud base, we add the relative humidity, we close that again. I'm going to save it, and I'm going to say, I'm going to save it over that because I didn't like the previous one, so that's fine. I'm coming to you in a few seconds, and then I'm just going to pull this one underneath that one, so that if I line them up nicely, then we can see how they track. Okay, Declan, did that answer your question? Declan?
I must admit that is extremely interesting. The fact that as the relative humidity goes down, the cloud base goes up. That absolutely does, I must admit, because I thought I saw something on like the previous graph, but of course it's really hard to pinpoint and see. So like using this method is very interesting because now it's clear. Yeah, you can clearly see the relation.
They're the mirror. They're like the mirror image of each other. So,
yeah, absolutely.
So what I'm going to do is I'm going to save that. Okay. What we could do is we could say, let's go back to visualize, and then what we can do, the visualize, what we're going to do is we're going to create a data table, SDG, and then here for our metrics, we want average, and we had cloud base. Okay, so let's go here with a cloud base. So I'm going to say here cloud base in meters. And then I'm going to say add a metric. And I'm going to say the metric is, once again, it's average, relative humidity. You'll see where this is going very quickly, okay? Okay, and then, so we do that, add those two, and then we say buckets. In terms of the split row, yes, I want date histogram. And then I want the field is here, timestamp created, that's fine. Interval is auto, that's okay. And then I'm going to say here date and time. Okay, that's great. And then what we do is we run that. Okay, so now you can see, now I've got a data table. Okay. Let's actually just save this data table, and I'm going to say 7-day cloud base RH. Save. Oh, I've got to put my kit name in, otherwise it's going to do an average of everybody's. Run that. Okay, so now what I can do is now I can download it. Okay, so I can say, okay, let's just take that, format a text. I can do that. Now what I've got is, and let me stop sharing and let me actually open that. Okay, so it's opening it now for me. I use numbers. So I'm just going to show it to you here. Let me just share my screen again. Where is it? Numbers. Here we go. Here we go. So now I've got it in. Now I've got it as a spreadsheet. So what I could do is that I could actually run a correlation between these two columns. And I suspect, based on, are you able to see my browser now? Are you able to see that dashboard again?
Oh,
No.
no.
Okay, there we go. So I'm prepared to bet that the correlation between those two columns is going to be very, very, very close to -1. A very strong inverse relationship between these two data sets. So the thing is that it's wonderful to have the visualization, but if we actually download the raw data, then we can actually start running statistical and mathematical equations based on that. So now, do you see, now it starts getting really interesting, doesn't it? Okay, guys, is that it? Okay. Okay, so is that it? I think that's it. Great. Okay, so thank you all. I'm very happy to do more of these sessions. Just let me know, and we can schedule something. So I'm looking forward to you. You know what? Play around as long as you save it as your own visualization, and you can never delete the data on the server. Play around, go crazy, enjoy yourselves. There's plenty of scope for that. Okay, great. Ruby, thank you very much. Thank you, everybody. And hopefully I'm going to see you all on Saturday. Great. Okay, thanks. Thank you. Cheers. Bye now.